Let's take a look at this system of two linear equations. We're supposed to again solve these two equations for x and y, and keep in mind that the letters a, b we treat like regular numbers. So what we're supposed to do first, look at the first equation. The first equation is already solved for y. So what I can do, I can substitute y in the second equation by a square x. And someone is going to ask what I'm going to achieve by that. I'm going to eliminate one of the variables in the second equation, and I'm going to have one equation with only one variable, or we can say one unknown. So I'm not going to even copy down the first equation. I'm going to go straight to the second one. So copy down 2ab squared plus a squared b to the fourth equals b squared, and instead of y I'm going to write a squared x plus 2ax. Okay, as I said, please notice we have one equation with one unknown. Because I have no x on the left side and I have two terms with x's on the right side, I'm going to copy down the left side. I have 2ab squared plus a squared b to the fourth equals, and because I'm looking for x, I have to factorize x, and inside of the parentheses I'm going to have b squared a squared plus 2a. Okay? In order to find x, I have to divide both sides of the equation by whatever is multiplied to x. Divide both sides by b squared a squared plus 2a. And I have b squared a squared plus 2a. Okay? This term and this one is going to cancel out, and I end up with x equals 2ab squared plus a squared b to the fourth over b squared a squared plus 2a. Now, let's take a look what we can do next. From the numerator, I can factorize a b squared. And inside of the parentheses, I'm going to have 2 plus a b squared. From the denominator, I can factorize a. I have a. And inside of the parentheses, I'm going to have b squared a plus 2. A and a will cancel out. And what I have in this parenthesis and what I have in this parenthesis, I have 2 plus ab squared. And in the denominator, I have b squared a plus 2. Keep in mind that anytime we have addition and multiplication, we can change the order and we can get b squared, open parenthesis, 2 plus a b squared over, I can write 2 plus a b squared. Okay, so 2 plus ab squared is going to cancel out with 2 plus ab squared. And I end up with b squared. So I can say that x is equal b squared. We found x, now we can find y. in order to find y, I'm going to use first equation, because first equation is solved for y. So I have a square x is equal y. You can rewrite this as y equals a square x. Instead of x, we're supposed to write b square. So I have y equals a square b square. And this is my y. Now, in order to verify that our answers are correct, we're supposed to simply substitute every x in our original equations and every y by these terms. Okay? So let's verify it. Now we are ready to verify if our answers are correct. So copy down the first equation. We have a square x is equal y. A square x we have to substitute by b square is equal y we have to substitute by a square b square. A square b square. As you can see, the left side is equal to the right side. So we can say that these expressions for x and y are okay. So, but this is just half of the proof that our answers are correct. We're supposed to also verify the second equation. We have 2ab square plus a square b to the fourth is equal b to the second y is equal a square b square plus 2a and x is equal b square. Okay, so copy down the left side. We have 2a b square plus a square b to the fourth is equal b square times a square b square is equal a square b to the fourth plus 2ab square. So let's take a look at the left side. We have 2ab square positive, and we have positive 2ab square also on the right side, and on the left side we have a square b to the fourth, and on the right side I have a square b to the fourth. So we can say that the left side of the equation is equal to the right side of the equation. So we can say right now that we are 100% sure that the ordered pair x equals b square and y equals a square b square is the solution to this system of two linear equations.